Okay, good day. This is AP Calculus. I am Mr. McCulley, and this is the presentation for section 8.5, Rational Functions and Partial Fractions. Now, if you recall, we did have a section of partial fraction review in the summer review materials. So there are a couple examples on there if you need to go back. And I'm going to go over an example here today. It is a fairly in-depth and involved process, so let's get to it. All right, so our goals for today, we are going to be finding partial fraction decompositions, and then we're going to use that partial fraction decomposition to integrate rational expressions. So first, a little bit of background information. So let's recall what a rational function is. A rational function is a function that is defined by the ratio of two polynomial functions. And so just real quick, jumping ahead a little bit, here is the integral of a rational function. And so when we want to use partial fraction decomposition, we're going to be talking about a rational function where the numerator and the denominator have degrees that are either equal or the denominator is greater than. If the degree of the numerator is greater than the degree of the denominator, you're going to want to divide first, and then you may have to do partial fraction decomposition on um, the remainder part. So anyway, let's talk about finding the decomposition of a rational function, which is going to be a polynomial n of x over the polynomial d of x into partial fractions. So the first thing we're going to do is we're going to divide if it's improper, and that's what I talked about just before. So this is really me reiterating that. So if a fraction is improper, the degree of the numerator is higher than the degree of the denominator, you need to divide that first. And then we're going to factor the denominator. And then for each linear factor of the form px minus q to the m, the partial fraction decomposition must include the following sum of m fractions. So if it's repeated, you have to have that px minus q, and then px minus q squared, and then all of them up to px minus q to the m. And then for every quadratic factor, and when they say it's a quadratic factor, that means that it is then irreducible over the real numbers. So there are some quadratics that cannot be factored down into linear factors. And so when you get one of those, you have to make it ax squared plus bx plus c on the bottom. And then on the top, you have a linear factor, b sub 1 x plus b sub c. Now I'm probably, just to keep this this video fairly short and manageable, I'm going to do one example here, and I'm probably going to have to do another example in class because, like I said, they are fairly involved, and you'll notice that there aren't very many in the practice work. So there are some guidelines for solving the basic equation, and those are on page 560 in the book. But let's get to one of these. So I'm looking at this particular problem, and I want to do the integral. And we've got to do a lot of work before we can even get to that integral. So the first thing we want to do is we want to, and I need the proper tool, we want to take this thing and we want to factor the denominator. All right, so first thing I want to put a line here because we're not even worried about the integral yet. We've got a long way to go before we can do the integral. But the first thing I want to do is I'm going to go 5x squared minus the 12x minus 12, and then I'm going to factor the denominator. Now, I see this denominator right off the top. I can take an x out of both terms, and then I'll have x squared minus 4, which is a difference of squares. And I know I'm moving fast on this, but again, you should know your factoring by now. So I'm going to do all that in one step. I'm going to say that this is x times x minus 2 times x plus 2. All right, so we're trying to get this into a decomposition of manageable factors. So here's what we're going to do. I don't have any repeated ones, so it's not necessarily a situation like this, but I don't have any repeated factors. So I need a factor for, or I need a partial fraction for each of these factors. So I'm going to go a over x, that first one, plus it's going to be b over the second one, x minus 2, plus c over x plus 2. All right. So this is going to be my partial fraction decomposition. And so again, when you're adding fractions, to add the fractions, you have to have a common denominator. So this is the common denominator, and these are all the partial fractions that I use to get that big common denominator. So on this one here, we are going to multiply both sides by the denominator of the original. So I want to take this 5x squared minus 12x minus 12 all over x times x minus 2 times x plus 5 equal to or a over x plus b over x minus 2 plus c over x plus 2. And we're going to multiply this whole thing, and I don't know why did I put a 5 there? I did, and that's too big, and I messed it up. Well, let's see if we can fix it here. So I've got my x plus 2. Let's keep it correct. And so I want to multiply this whole thing, both sides, by x times x plus 2 times x minus 2. And when I do that, on the right-hand side, all of these cancel out all of these factors cancel out all of the denominator factors, and I'm left with just 5x squared minus 12x minus 12 is equal to. Now, when I multiply x times x plus 2 times x minus 2 times a over x, this x cancels out that x, but I have to multiply by these two factors. So I'll have a times x plus 2 times x minus 2. And then I'll multiply, I got to distribute this expression to the b partial fraction. And when I do that, the x minus 2 will cancel with that x minus 2, and I will have b, and then this x and the x plus 2 don't cancel, so I'll have x and then x plus 2. And then when I multiply x times x plus 2 times x minus 2 times the c over x plus 2, the x plus 2 in both of these two terms, they cancel out, and I will have just c times x minus 2. Now you'll see in the book where it says choose, and they call it convenient, C-O-N-V, let's see here, I before E-N-I-E-N-T. I'm not sure I'm spelling that right. You guys can correct me in class. Convenient. Anyways, values for x. Now, when they say choose convenient values, a convenient value is a value that's going to cancel out something here. So my first choice is I'm going to say let x equals 0. Now, why is that a convenient value? Because when I plug in 0 here and I plug in 0 here, these two terms, they are going to cancel out. And all I'll have is a to solve for. So let's do that. All right, let's bring this down. All right, so I'm plugging in 0. I've got 5 times 0 squared minus 12 times 0 minus 12. And then it'll be a times, when I plug in 0 in for x, I'll get 2, and then I'll get negative 2. But when I plug 0 in for x here, I get b times 0 times x plus 2. That's going to give me 0. And when I plug in 0 here, I'll get c times 0 times, and it ends up being negative 2. And so I'll get another 0. All right, so this is 0, this is 0. I get negative 12 is equal to negative 4a, meaning that a is equal to 3. So I know that this fraction here is going to be 3 over x, and that's great. And I won't need to do it for this one, but you may have to keep that in mind if you run out of convenient values to plug in for x. But for this particular problem, we're going to have lots of convenient values. And so now I want to solve for b, so I'm going to say let's let x equal 2. And when I let x equal 2, well, this thing is 4. This factor up here is 4. This factor is 0. This factor is 2. That factor is 4. This is 2. And this one becomes 0. So when I plug in 2, I get 5 times 2 squared minus 12 times 2 minus 12 is equal to, well, since this becomes 0, the a term becomes 0. This whole term here becomes 0. And then I have b times 2 times 4, because when I plug in 2 for x, I get 2. 2 plus 2 is 4. And then when I plug in 2 here, 2 minus 2 is 0, so I get 0 there as well. All right, so I get, let's see here, 2 squared is 4, 4 times 5 is 20, and then it will be minus 2 times 12 is 24 minus 12. And so and then 2 times 4 is 8, so I have 8b, and then that, let's scooch this up again. This, let's see here, 20 minus 24 is negative 4, minus 12 is negative 16 equals 8b, and so my b value will be negative 2. And so now I know that this fraction is going to be negative 2 over x minus 2. And so the last convenient value that I'm going to use, I'm going to say let x equal negative 2. All right, well, if I let x equal negative 2, these all have values, but negative 2 makes this 0, so this a term becomes 0. Negative 2 makes this factor 0, so this b term becomes 0. And then I have negative 2 and then negative 4 here. So plugging that in again, I'll have 5 times negative 2 squared minus 12 times negative 2 minus 12. And again, when I plug in, I'll leave it up there and see if I can sneak it in there. When I plug in negative 2 into this term here, I'll get negative 2 and negative, or I'll get 0 and negative 4. And so the a term becomes 0. When I plug in negative 2 there, I get 0. So this term becomes 0. And then when I plug in negative 2 here and here, I've got c times negative 2 times negative 4. All right, so let's move this down and do some calculations here. So negative 2 squared is 4 times 5. That gives me the 20. And then I'll have negative 12 times negative 2 is positive 24. And then I'm minus 12 here. And then that's going to equal to 8c. And so 20 plus 24 is 44. Minus 12 is 32. That's equal to 8c. So my c value is going to equal to 4. All right, so you know what? Let's just rewrite it. Now I can say that 5x squared minus 12x minus 12 all over, let's see, it's x times x minus 2 times x plus 2 will be equal to, and let's keep them straight now. So I've got 3 over x, and then just so I got to check just so I don't make a mistake in which order I got. It's going to be b over x minus 2. So plus negative 2 over x minus 2, and then finally it'll be plus the c value is 4 over x plus 2, and I think that's correct. Now this is your partial fraction decomposition. All right, but the question didn't ask for the partial fraction decomposition. It asked for the integral of this particular rational function. And so since the rational function is equal to this partial fraction decomposition, the integral of this rational function should be equal to the integral of this partial fraction decomposition. So we can integrate we can integrate and say we're going to integrate with 3 over x, and then it'll be minus 2 over x minus 2 plus 4 over x plus 2 dx. All right, well, since it's a sum, we can integrate them individually, and I'm going to move these constants out as well, the 3, the 2, and the 4. So I have 3 integral 1 over x dx minus 2 integral 1 over x minus 2 dx plus 4 integral 1 over x plus 2 dx. Now, I'm quoting the integral of 1 over u du is equal to the ln of absolute value of u plus c. And I don't have a u here, it's just x, so that will be this is going to be the ln of x, but I have to consider the derivative of the x plus 2 and the x minus 2. The good news is that when if I say let u equal x minus 2, then du is going to equal just dx, because the derivative of x is 1 and the derivative of a constant is 0. So I don't have to do any more with constants out front. So that's a good thing that we don't have to worry about. And I can just go and do all of the ln's without any more substitutions. So this becomes 3 ln of the absolute value of x minus 2 ln of the absolute value of x minus 2 plus 4 times the ln of x plus 2, and then it's plus some constant c. Now, we could probably do some combining. We could probably bring some exponents up and all that other stuff, but we are going to say that that is good as it is, just like that. All right. Let's take a look here. Got 16 minutes, and I think we'll call it short like that. I'll do an example in class where we have a repeated factor. I'll do one of those sometime this week or next. And so we will cut it short, and we'll talk about the Star Wars fun fact of the day. The planet Jeddah is introduced in the movie Rogue One, a Star Wars story, and the planet Jeddah is where they found the Kyber crystals, which is a energy crystal that they use to power the Death Star you see here. And for some odd reason, in Star Wars Rogue One, they always had the super turbo laser there in the bottom half or the bottom hemisphere, and I'm not quite sure why that is. But anyway, in Jeddah, it was an ancient Jedi temple place, and you can see that there used to have massive statues here with lightsabers. And the reason that Jeddah was such an important planet to the Jedi was those Kyber crystals not only power the super laser on the Death Star, but they power the lasers in the lightsabers for the Jedi. Well, folks, that's all I got for today. I hope you have a great day, and I will see you in class. Have a good one. Goodbye.